This is my real-time clock breadboard prototype. Here's my real-time clock displaying the live time. This project uses an AT1085, an RTC, and a 4-digit 7-second display to write, read, and display the live time. The project begins on the RTC breakout board. On the breakout board is the RTC, which is an 8-pin chip that can count the time. This is done with a 32K crystal oscillator, in which every 32K oscillations, 1 second is counted. However, the RTC can only keep track of time, but it must be told the time initially before it can start counting. To program the time on the RTC, a function setTimeDate is created in the setup. First, the function retrieves the live time. This is done with the time macro that is predefined in Arduino's code. This function will retrieve the live time and print it out as hours, minutes, seconds. However, this result is returned as a string, and numbers are not defined as integers in string, so scanf is used, which is a predefined Arduino function that will retrieve numbers from a string and print them out as integers. Next, the code sends out the live time to the RTC. To do this, it must begin communication with the RTC, then enable the register it wishes to communicate with. Since we want to write to the seconds, minutes, and hours, we will write to registers 0, 1, and 2. This is done with tinywirem.write dec to BCD seconds, minutes, and hours. Dec to BCD and BCD to dec are two functions that convert decimal into binary converted decimal and vice versa, since the RTC can only receive BCD and the Arduino cannot. After the time has been set, the Arduino can retrieve the time from the RTC within the loop function getTimeDate. Since we only want to retrieve the minutes and the hours stored in the RTC, we will begin by writing to register 1 and end at register 2. Next, the integers minutes and hours are returned and are converted from binary converted decimal to decimal. Since we want the minutes and hours to return in order of hours then minutes, we must move these values into a 4-integer array, with each integer being its own value. To do this, the tens digit of the hours is isolated with hours divided by 10 because there are no remainders. If the time is 12 o'clock, 12 divided by 10 will be 1. The same thing is done for the tens digit of minutes. Next, to isolate the ones digit of hours and minutes, mod is used, where the remainder of hours divided by 10 is our value. For all these integers, the buffer will not hold what we've calculated. Instead, it will return the value of the corresponding integer to what we've calculated in the segments array. The segments array is an array that holds all high and low values for each segment A to G for every number. After we've retrieved the live time, we need to print it out on the 4-digit 7-second display. To do this, we use bit shifting, along with 2 bit shifting registers. In the function showTime, a for statement is created, in which each iteration will display the number for each digit. The 4-digit 7-second display cannot display different numbers at once, so it uses persistence of vision to achieve a similar effect. For a number to be displayed on a digit, the digit must be enabled. After the latches are set high and low, the code can shift out the digit that is enabled. In the first iteration, this digit will be 1, as 1 bit shift 0 equals 1. In the hardware, the only digit pin active will be the rightmost digit. Next, the buffer sends out the segments for the respective integer of said digit. Here's a diagram of all the bit shifted values, and here's a comparison to the real 595 registers. The 4 rightmost slots are connected to a digit pin, and the 7 last slots of the first 595 are connected to the segment pin.